My name is Maddie, and today I will be sharing with you about shark families under the Lamniformes order. Specifically, I will be focusing on geographic range, body size, feeding styles, and threat levels for each family. To begin, I will introduce you to all the shark families under this order. We start with thresher sharks, which arose in the Eocene epoch. On average, the sharks in this family are about 4.5 meters long and weigh around 440 pounds. Being exploited in the past, all three extant species in this family are currently listed as vulnerable by the IUCN Red List Database, and they are all currently declining in numbers. The feeding style of this shark family is unique as they use their long tails to stun their prey before consuming it in large chunks. Next is the basking shark, which arose in the late Triassic. The sole member of this family is Cetiorinus maximus, which is currently listed as vulnerable and declining in numbers. Cetiorinus maximus is massive in size, weighing in at about 5,000 pounds with an approximate length of 7 meters. It sustains itself by filter feeding on zooplankton, and as you can see from its gaping mouth in the photo, it's able to consume massive amounts of plankton as it swims. Moving on to mackerel sharks, who arose in the early Cretaceous. This family is more morphologically diverse than the others and contains 5 species which all actively hunt prey. In the bottom left-hand corner, you see the short-fin mako shark, which is endangered and decreasing in numbers alongside the long-fin mako. The great white, shown on the right, along with the porbeagle shark, are also included in this family, and both are listed as vulnerable and decreasing in numbers. The salmon shark seems to be the only species doing well in this family, as it is listed as least concerned with stable numbers. There is high morphological variation between species in this family, but on average, they are about 3 meters long and weigh about 550 pounds. I chose to conservatively list this family as vulnerable for the purposes of my research. The sole species in the megamouth shark family arose in the Oligocene epoch. Similar to basking sharks, the megamouth shark is a planktonic filter feeder, but it is about half the size, weighing in at about 2,500 pounds and measuring about 4.5 meters in length. This deepwater species is listed as least concerned, but changes in species numbers are currently unknown. Next are goblin sharks, which arose in the early Cretaceous. This family contains 1 species, which is listed as least concerned, with unknown changes in species numbers. You can see from the photo why this species has been commonly named the goblin shark. It's not very pretty. The goblin shark is rare and poorly reported in the literature. From what has been documented, the goblin shark is about 4 meters long and weighs approximately 450 pounds. Sand sharks arose in the early Cretaceous. On average, the sharks in this family are 4 meters in length and weigh 200 pounds. All 3 species in this family are classified as vulnerable and declining in numbers. Evidence from the primary literature indicates that this family underwent adaptive radiation following the KPG mass extinction event. The crocodile shark family contains only 1 species, which is listed as least concerned and increasing in numbers. Out of all the families under the Lamniformes order, this is the only one whose species are increasing in numbers. As you can see from the photo, this shark species is much smaller than the ones I've gone over in previous slides. It is a little less than 1 meter and weighs about 12 pounds. According to the literature, the crocodile shark has low commercial value and is rarely kept by fishers. Moving to the extinct families, we start with Anacorasidae, which arose in the early Cretaceous and went extinct during the Neogene epoch. This shark's feeding style is unique, as it is presumed to be a scavenger of vertebrate carcasses. Based on dental morphology and comparisons to extant species, the sharks in this family were about 2.5 meters in length. Data on body mass could not be obtained for any of the extinct families, as it was completely absent from the literature. In general, data on this family was limited. The Cardobiodontae family arose in the late Cretaceous and went extinct shortly after. Only 1 occurrence point was found on the Paleobiology Database. Based on the few recordings and tentative data found in the primary literature, the sharks in this family were approximately 3.5 meters in length. Cretoxyrhinidae arose in the early Cretaceous and went extinct during the Neogene epoch. The sharks in this family were active apex predators in the open oceans and measured to be approximately 2.5 meters in length. We finish with one of the most exciting families in the Lamniformes order. The Otodontidae family contains famous shark species like the megalodon. In the right-hand photo, you can see how large this species was. The great white looks dwarf-like in comparison. The sharks in this family were over 8 meters long on average. Here you can see the summary of the data I collected using several primary literature articles, the IUCN Red List Database, and the Paleobiology Database. Using that same data, I created a separate data set based solely on threat level. Only variables of significance were included in the table. This figure shows the longitudinal and latitudinal ranges of each family under the Lamniformes order. As you can see, geographic ranges varied based on the family in question, but no significant patterns could be observed. Similar to the previous figure, this chart shows how the longitudinal and latitudinal averages varied between families. More variation was observed in longitudinal averages. The only geographic variable that appeared to affect threat level was longitudinal average. Extinct families seem to have been located more southwards of the equator than extant families. When comparing extant families, you see that vulnerable families are located more near the equator, while least concerned families are located farther south. This figure shows the variation of body length between the families. Most families were about between 2.5 and 5 meters in length, excluding Cenouridae and Otodontidae, which were much larger, and the crocodile shark family, which was much smaller. Here you see the extreme fluctuations in body mass between the extant families. Most families were between 200 to 500 pounds, excluding the filter feeders, which were much larger, and the crocodile sharks, which were much smaller. Extinct families were not included due to data deficiency. In this graph, you see how average body mass varied between threat levels. Here, you see how average body mass varied between threat levels for extant families only. Vulnerable families were, on average, over double the mass of least concerned families. This was by far the strongest relationship I found, indicating that the large body size may increase extinction risk for shark families under the Lamniformes order. So, why should you care? Well, this research shows that the majority of shark families and species under the Lamniformes order are currently vulnerable and decreasing in numbers, a pattern that has been observed in many other taxa. Sharks are apex predators which play crucial roles in maintaining ecosystem balance. Future shark extinctions will have cascading effects on the rest of the food web, and the consequences are difficult to predict. Clearly, data on shark families needs to be improved so we can better predict their future outcomes. Body size appears to have an effect on their extinction risk, and that needs to be considered in our conservation efforts. Without the primary literature, IUCN Red List Database, and Paleobiology Database, I would not have been able to perform this research. Thank you so much for your time and attention.